Hello, everyone. Welcome to FOA. How are we doing so far? Let's see some hands. Let's see some thumbs. Are we doing fine? How was the schedule? How was the coffee? How's the vibe? Everything doing great? Okay, let's start off. As mentioned, my name is Thijs, and if you want to follow me on Twitter, you can do so. This is my Twitter handle, my full name. I know it's a bit of a weird name, but that's a Belgian thing. I'm a tech evangelist at a company called Combell. We do web hosting, and as Ian mentioned, I'm also involved with the PHP community, run a local community called PHP Benelux, where we just run the Belgium, Dutch, and Luxembourg PHP community. Not much happening in Luxembourg, though. So let's talk about Vagrant right now. Let's see a show of hands. Who uses Vagrant right now? Oh, that's interesting. That's good, because maybe you'll learn a thing or two. Now, Vagrant, and that's the definition I got off the site, allows you to create and configure lightweight, reproducible, and portable development environments. And I marked development environments because that's what it's all about. It's not about having a production system up and running or a staging system. No, it's about the box you develop your code on. So it's written in Ruby by Mitchell Hashimoto in 2010. And it's actually an orchestration layer on top of, first of all, VirtualBox, and in later stages they added support for VMware. So it's basically a scriptable way of maintaining your virtual machine. So let's see some more show of hands. Who develops code on its local machine? Let's say WAMP, MAMP kind of stuff. Ooh, that's a lot of people. Sorry, you're disappointing me with that, but hopefully at the end of this talk we will be changing this. Now, who has a separate development virtual environment on its local machine? I asked the question who uses Vagrant. I see more hands right now, so that means you're doing it differently. How are you doing it? Just shout out. Who uses VirtualBox without Vagrant? VMware Fusion or regular VMware? Okay, so maybe at the end of this talk you'll be using this nice little tool to easily deploy, create, and manage your VMs. So who uses a remote development box at the office? Okay, it's perfectly viable. So let's get back to Vagrant. Vagrant tries to solve a specific problem, so why would you use Vagrant? This is the main reason why we do it. We all know the guys, it works on my machine, and then you have this awful joke, well, back up your laptop, it's going to put your laptop in production. This is what we're trying to avoid here. I work at a hosting company. I did 6.5 years of tech support, and I have to worry about other people's code, and that's a bad thing. That's a really bad thing. And a lot of people say, well, it works on my machine, why doesn't it work on your servers? So we're trying to avoid that, and that is actually the main goal of this talk. This is what we're here for, or what I'm here for. So what we want to do is have an environment per project, not a monolithic system on which you run all your code, because some code is going to run a specific version of PHP or Ruby or Python or whatever you use. Some things will be clashing, so you want sort of separate silos per project it can easily set up, easily tear down, and easily to script. And what you want to do is, if you script it, it needs to be in a very understandable way. It shouldn't be really complicated, like complicated XML. No, just a file with a certain markup that says how you want your machine being done, what software should need to be configured, all sorts of properties. And make sure that your development is like test, staging, and production. I added the tilde. You'll never or hardly ever have an exact copy of production. Having an exact 100% copy is ambitious. But if it's very similar to test, staging, and production, at least you can get your hopes up that your code will be working on that system. So easy to define, transport, and also, and this is an important one, easy to tear down as well, because all these images, all these virtual images will consume resources, especially disk. And if you're done working on a project for a while, you might want to tear it down and work on something else. And this is an important one as well here, shared across the team. So that configuration, which I will show you later on, you could just transport that along in your version control system, shared amongst your team members. And if we would run Vagrant, and I hope you could read this, try to make the print as big as possible. If you run the Vagrant command, because it's basically a command line tool, if you run it, it will show you a bunch of options. And this is what this talk will be about, showing what these options mean and how you can reach the end goal. So if you run Vagrant init, because that's the main one we're going to do, and it's such an easy joke, right? Being in London, init, using the term init here. I'll be light on the jokes. We had plenty of jokes during the opening keynote, I guess. So Vagrant init, if you run that one, it will give you some verbose information on how you could create your Vagrant file, and what does that Vagrant file do, because that's an important one to know. Vagrant file is that scripted way of selecting a base box, and a base box is what the next chapter will be about, because you need a basic VM that is prepped, in which you can deploy all sorts of things or install also all sorts of things. And then you can choose your virtualization provider. That will mainly be either VirtualBox or VMware. Twiggle around with VM parameters, such as CPUs, number of CPUs you want to configure, RAM settings, et cetera, networking settings, SSH settings, mounting your local file system, which is very convenient for developers, and finally provisioning the machine. So that's what we're going to do. So if you run Vagrant init without any options, it will drop you a Vagrant file, and if you open it in your text editor, you'll basically see that it has the Ruby markup for your editor. So it's plain old Ruby, but with a specific syntax. So you're going to configure a machine. The 2 means that we're going to use Vagrant version 2, which is important because it adds a lot of nice features. And we're going to namespace all the properties as config, and then you can say config VM box is base. So there's this sort of convention that you have a base box that represents that Linux image you're going to run everything on. And that base box is going to be cloned every time you make a box. You can also add some specific parameters. Say we're not going to use a base box, we're going to name it precise32, which is an Ubuntu version. And this is where I'm going to download it. And it's going to just put it in the file. It's not going to actually download it. That happens when you start it up. But it's going to pre-provision everything you need. And you can add whatever box you want. You can have whatever distro you want. As long as you stick with Linux. And then the magic command, and this is like, if you have to remember one thing from this talk and one thing only, is this command, vagrant up. It's all you need in life, vagrant up. And then you just press the return button, and it will just give you some verbose information. Since the precise32 box is not really on the system right now, it's going to download it. You can see the progress here with a sort of estimation. And once it's added, it's going to store it in your system globally. So in the future, when you have that box in there and you want another project using it, you don't need to download it anymore, so it's there. And then it says all the stuff it does to your machine. It imports the box, does some netting, setting the name of the VM, port forwarding, networking interfaces. This is a specific one I'll mention, booting it up, configuring it, and mounting a folder. So you see what it does. But back to base boxes, because boxes are important. There is a place where you can download them. It's a sort of community site called Vagrant Boxes, and it has a bunch of those. It's a community initiative. If you want to tailor your own boxes, there's this project called VWE by a guy named Patrick Dubois. He's the guy who invented DevOps, the term DevOps, and he maintains this project, and it's an easy way to start from a basic ISO and create a Vagrant box. So you could tune it, you can strip off stuff you don't need. It's a really good tool. So when we type in Vagrant box, you're going to see this kind of stuff happening, the basic stuff, right? Adding, removing, listing, repackaging. And I have some code examples here. Like this slide is heavy on code examples, so you'll see lots of this. So if you box list it, you'll see that the machine we previously imported is there. It's a VirtualBox machine called Precise32. We could remove it. We can add it again and mention where it needs to be. Now, contrary to the previous slides where we did the Vagrant init with this box, this will actually download the box. This could be a URL or a local file. It will import it and make sure it's available when you boot a machine. And if you want to redistribute that box, let's say you just did a Vagrant box add from a specific file. The file is no longer on your local folder. It's just stored internally in the system. You can make it reappear by doing Vagrant box repackage, and it will come as a package.box, and you can put it online, redistribute it to your team, whatever you want to do. Now, I would like to remind you that all of this, the box management or downloading boxes, can be done in your Vagrant file. Just mention config VM box and the URL, and it will download it if you don't have it. And this is what a box looks like. The box is just a tar.gz, a sort of archive containing a VMDK, an OVF file, a meta.json, and the meta.json usually contains the virtualization provider, either VirtualBox or VMware, and a Vagrant file that bootstraps other Vagrant files, because that's the cool part. When you type Vagrant up in a folder that contains a Vagrant file, it will bootstrap the entire thing. So now that we know what Vagrant does, and now that we know how we can work with base boxes, let's get up and running. So let's get starting. Let's start, stop, suspend. Let's do all the cool stuff. So if you do Vagrant up, again, that's the command you'll love by the end of this talk, or maybe next week when you toy around with it, you'll just send me a tweet if you like it. For the people who haven't tried it, just send me a tweet. So if you do Vagrant up, it will do all of that stuff again when the VM does not exist. But when it exists, it will just show you some basic information, like it was already running. I'm not going to bother making it boot. Now, a reminder, and maybe a hint for you, who has a laptop containing an SSD? Who doesn't? This will take some time doing a Vagrant up. If you don't have SSD, could take some time, could take a couple of minutes. So if you don't want to destroy it, because Vagrant destroys the command you're going to tear down your entire environment with, if you just want to suspend it or halt your machine, there are commands for that as well. So with the status, you can see what's happening. It's running, it's actually running. And when you do suspend, it will just pause your VM and keep the current machine state on disk. And when you resume, when you do Vagrant resume or just Vagrant up again, it will just restore the machine. There are cases where you don't want to do that, and you just say, I want to shut down, and you do Vagrant halt, it shuts the machine down. And it's still when you open your VirtualBox or when you open your VMware, you'll still see the machine, but it'll be just shut down. And then as I mentioned before, if we want to destroy the machine, if we want to tear it down, just do Vagrant destroy. It won't only shut it down, it will remove it from your virtualization provider. So it will be completely gone, won't be consuming any RAM, CPU, nor will it be consuming disk. So that's what it basically does. So what have we learned so far? We've learned how to set up what a Vagrant file does. We know how we can import boxes. We know how to set it up, tear it down. But now we have that, we need to connect with it. So connecting is an important part of Vagrant, and a part that is made incredibly simple. You just type the Vagrant SSH command, and it will automatically log in. No need to know the IP, no need to care about passwords or your own keys. It will just go in there, do sudo su, and your root in the machine. Now in the background, so when you go on that machine and when you root and you go to the authorized key files, you'll see that there is a public key automatically provisioned. And it says here very specifically, Vagrant insecure public key. So it's something that Vagrant manages for you. And when you type the command Vagrant Ssh Config, you'll get the Ssh config for that. So there's been a default there where there's a default host, a default user, a default port. And what this does actually is make sure that you do a local SSH connection to port 2222. And it will be port forwarded to the IP. In this case, the machine itself will log in using the user Vagrant, and we'll be using this insecure private key to match the public key. And that private key, like this is my computer user stays.vagrantd, so there's this global space on my laptop here where the key is stored, and this is what it looks like. Nothing spectacular. You can use the key, there's no privacy involved here. The key aspect when we run these Vagrant machines, when it's up and running, when we connect it, is also the portability of the Vagrant file. I want to briefly touch on that because that's important. I mentioned already that you could use the Vagrant file. This is a GitHub project of an open source tool or an open source project called Joined In. And a lot of people want to contribute to it. And having the machine requirements often requires some documentation, like set up your machine as such, you need these versions. Instead of going to all that hassle, the maintainers just dropped in a Vagrant file, which is versionable as well. So if you need to change the specs, you could easily do so. And just clone it, clone the GitHub repository, just type Vagrant up, and you have some Puppet manifests that will provision the machine. We'll touch on Puppet as well as Chef. So what we want to do is share that Vagrant file, and as a consequence, share your entire development environment with contributors of public open source projects or just people within the company who are on your team. So what we're basically saying is infrastructure as code, and this is a big term coming from the DevOps community, having infrastructure there as code. So you remember this one, our little Vagrant file only containing the box and the box URL. Well, let's do some actual stuff with it. Let's provision it. Let's start with some networking, because that's something you want to care about. Because if you want to connect not only through SSH, but with a web browser, let's say, you need to make sure how to connect to it. There are three ways of networking: public networking, private networking, and just doing port forwarding. The public networking just bridges to a network interface and just let it handle everything networking related. So you're part of the public network. Everyone else could manage or access your box. If you don't want that, you can do some regular port forwarding. It doesn't add an extra network interface to the machine. It just says, well, the port 80, which is by convention the web server port, will be linked on your computer to 8080. So if I type localhost 8080, I will end up being within the machine. So that's what it does. Personally, I prefer private networking because it's simple, it's straightforward. You just choose an IP within the private IP space. Watch out if that is the same IP space of your internal network or your company. That might generate some IP issues. And let's see the examples here. This is how you do it within the Vagrant file. So a private network, just add within the global configure, add config VM network, private network IP, run Vagrant up, and it will take care of everything. Now, mind you, we didn't choose port forwarding, but we're still seeing some port forwarding here. This is still something we see. Why? If you pay close attention, this means the 2.2 goes to the 2.2.2.2. This is for Vagrant SSH. So you SSH on this port and you end up in this machine. So this is required for just SSH connections. If we use port forwarding, you can see the extra line being added. So it's added to adapter 1. Port 80 internally is matched to 8080. So it's pretty clear. When you do a Vagrant up, you see what happens. And finally, when we choose public networking, and when you do the Vagrant up, you will see an option, you will get an option which interface do you want to bind it to, and I chose one to my Wi-Fi. I tapped enter, and it just linked. If you want to pre-link it, there's an option of bridging, and then you have to mention your network interface you want to link it to. I don't consider this very convenient. In some cases, you might use it. I always stick with private networking. This is the #1 reason, synced folders, why you should pick Vagrant over constantly deploying to a local VM, because it has a built-in system of mounting your local file system, not just the local file system, but the current directory in which the Vagrant file resides, just mounting it to the system. So when you're in your IDE, you can have your local file system available, and you can just save directly from your editor or IDE, which is very convenient for developers, because you don't want to change a piece of code, upload it to your VM, and then test it, and the uploading or deployment process might take some time. No, it's instant. You press save, you refresh your browser, you see your result. And by default, there is a mount, a /vagrant mount. So that means your current folder is available on your guest OS, and when you go to the /vagrant, you just see your local system. And when you change something on your computer, it's going to be changed there. So in a lot of cases, people will link this folder to their web server root. What I tend to do is add another sync folder. Let's say you have your project and the public files are located in web. Well, I'm going to link them to var /dub, and when you install Apache, you'll immediately have a link, and you can immediately navigate through it. And you can see it here. When you do Vagrant up, you will see this happening. So we did quite a number of things already. Let's tune some VM properties. This happens also through the syntax. This is not a complete Vagrant file. This is just a snippet that is relevant. You just have to shove it within the main configuration block. What we do here, these are some stuff. This is some stuff. I put a Vagrant file online because I do some training as well, and I added a Varnish installation, and I wanted to distribute it to Vagrant, and I did it, and then some clever person said, you might want to add these parameters. Some of these solve kernel panics. Other ones help you have better DNS resolving. It's just internal magic from VirtualBox, but it actually helps. The only parameters that are very useful to you is memory and CPU. This is how you can tune how big the box is. Like if you need some extra horsepower in it, you might want to increase this. This is the way it works. So these are the basic steps. This is how you manage a Vagrant box. When you have it up and running, you won't have any specific software on it. This is the next chapter, but you'll have it tuned, the machine tuned the way you want. And then we'll be dealing with the most important part, provisioning it, making it look like production, making it look like test and staging. Now, provisioning, it could mean anything, but what it basically means to me is adding specific software to it, so using packages to do that, creating configuration files where you need them, execute certain commands to prep your system, create users, manage services, and this all needs to happen automatically. You don't need to care about that in theory. You have people in your team who are going to write all the provisioning you need, and just type again, and I'll be repeating that a number of times, Vagrant up, machine comes up, provisions automatically. So having an exact copy or a similar, or as good as an exact copy of your environment is the main goal here. And we're going to use, there's several tools out there. There's a bunch of tools out there. I just marked the ones that I'm going to mention. Now this talk is called Vagrant Ssh and Puppet for the win. Well, it's going to be mainly focused on Ssh and Puppet, but you can do plain old shell, just Linux commands. Ansible is getting a lot of traction these days as well. Anyone who's heard of Ansible? It seems like the cool thing to use these days. I like Chef, I like Puppet. I personally prefer Puppet. I'd like to standardize on Puppet, but Chef is pretty awesome itself. You see different kinds here, solo client, apply agent. You can do a standalone way of provisioning where all the scenarios, how you're going to set up the software, are also in your code repository. You saw the screenshot of the joined in project. It had a Puppet folder, so it locally stores all the software you want to install, all the configuration files, services you want to manage. When you don't want that, and when you just want to connect to a configuration management server, you're going to use either Puppet agent or a Chef client. So it connects over TCP/IP to a centralized server, the same server that deploys all the code and the infrastructure to your production environment while you're going to connect and hook into the same one. But let's start with the beginning. Let's start with shell. Shell is plain, shell is simple, And shell is pretty powerful. Like I ran into this problem, a colleague of mine who is sitting on the third row there wanted to deploy a Symfony app in PHP, and it was insanely slow in its system. So I said, well, the cache folder, which is located in a Vagrant app cache, we want to have a RAM disk for it. So instead of just writing a complicated Puppet script for it, I just did config VM provision. What kind of provisioning? Shell. Where does the script reside? Well, it's inline, and then mount tempfs, 50 megs of RAM disk, good to go. Pretty simple. You can do even more than that. You can use full Ruby because it has full Ruby syntax, and you can do whatever you want there in Ruby to manipulate what's coming in. And if you want to partition it separately, have separate files for that, you can either use local files using, like in this case, script.sh, or you could download it remotely. But we're no longer going to talk about that. We're going to talk about the stuff that is actually built to provision machines, either Chef or Puppet. Anyone using Chef these days? Anyone using Puppet these days? How do the other people provision their machines, or aren't there, or are you not involved with the deploying of code or configuration? How does it happen in your companies? Manually, or have the hosting company take care of it? Probably. Okay, Chef and Puppet. Chef is a tool created by Opscode. It's written in Ruby in 2009. Now, it's an open source project, but it's company backed. They have an enterprise revenue model. And the same thing applies to Puppet. See the pattern here? It's written in Ruby. This one is written in Ruby as well by Puppet Labs in 2005, so that's the company backing it. Chef and Puppet, again, so Vagrant is written in Ruby, Chef is written in Ruby, Puppet is written in Ruby, a lot of stuff happening in Ruby. Now, as the introduction went, I'm a PHP guy, but I have to accept this. Ruby is big, Ruby is out there, and I think next time around, I'm going to be learning Ruby to even master this stuff more. So both of these tools written in Ruby, open source, enterprise model behind it, similar features, both standalone or server-side, you could choose. Supported by a large community. So if I had to say which community is bigger, I wouldn't be able to answer that question. It depends on the flavor you want. It's modularized, so the components you're going to download there are parameterized, modularized, so you don't need to figure out the nitty-gritty. They offer a nice little interface that you can add parameters. Let's say for MySQL server, the root password or the location of the data files, just going to abstract that for you. And they're going to use all kinds of stuff for file system, for templating. It's pretty easy. If I have to say how they differ, I would say in terms of the lingo, so modules, the way you modularize things, Chef calls these cookbooks. They're going to stick to the culinary naming there. You're going to have cookbooks, and within the cookbooks, the specific items are recipes, whereas Puppet just calls them modules and manifests. Now, the main difference, language-wise, is that Puppet just has its own DSL you could work with, whereas Chef is full Ruby, extended with a DSL. So if you're a Ruby guy, in a lot of cases, you're going to pick Chef, because it's just the way you like doing things. The approach here is it defines actions, whereas Puppet more or less defines states or on how you want it. It doesn't really say do this, do that. It says make sure it's like this, it's make sure it's like that. Whereas it is more procedural on the end of Chef, it will be more object-oriented on the side of Puppet. So instead of talking about it, let's just do it, right? How to use it? There's a GitHub repo by Opscode itself that contains modules for all the popular open source projects you can figure out. Web servers, database servers, all the components you want. You can just clone it to your directory where you want it. Make sure you link it in your Vagrant file through chef.cookbookpath. And if you want to include recipes, just use chef add recipe in your Vagrant file. I'll show you later on. And if you want to interface with all the attributes you can modify, you can just use chef.json and have inline JSON with all the parameters you want. Or when necessary, you can create your own cookbook. But in a lot of cases, I would advise you don't reinvent the wheel unless truly necessary. So this is what it looks like in the grand scheme of things. Again, this is not the complete Vagrant file. This is just a config bit that is relevant. So we're going to say we're going to provision our VM using Chef solo, namespace everything under Chef, and then say the cookbooks are located in the current directory under a directory called tools, Chef cookbooks. And the recipe I want to add basically comes from the MySQL cookbook, and it's called server. So we're going to install a MySQL server on the system. And then we use Chef JSON to parameterize whatever we need to do, and we're going to say the password for replication, for server, just server authentication using root, or the Debian built-in user is going to be foo, and you can connect with foo. Now, the layout of the cookbook is pretty straightforward, pretty plain and simple. There's a lot of directories and files there, but I marked the ones that are especially relevant. So we're going to have the recipes, and the default recipe is called default.rb, and there you're going to specify the main one. So in terms of bootstrapping, this one is going to get loaded first. Templates are stored in the templates default folder, so it's ERB style, so you could just drop Ruby style templates in there, and everything that it needs to be parameterized resides in the attributes folder. I'm going to show you some quick examples. These are not full examples because the code base is so extensive, it hardly fits on slides. So this is for MySQL, all stuff you could configure. But please note that the configurations might depend on platform families, so you're going to have a difference between Debian style or Red Hat style. So you need to make sure if you download one, it fits the infrastructure you have at the office. This is a server recipe, a pretty simple one, and this actually shows the power of Chef in this case. So they're going to have a group, so this is going to define a group on your Linux operating system called MySQL. It's going to create it. You're going to create a user called MySQL. It's going to reside in the MySQL group. And the location, so the home directory of that user, is predefined. Node MySQL data there, so that comes from attributes. You could tune that. And in the end, it's going to have a no login shell. And then based on all the packages that are located in the attributes as well, so in the configuration, you can loop through it, and it will use the package manager of your operating system to install it. So on Debian systems and Ubuntu systems, that will be apt-get. On a Red Hat, Fedora, or CentOS, that's going to be Yum. Packages could also be Ruby gems, or even PHP pair installs, or whatever you want. You can even configure it and write your own providers for it. Templates, as mentioned, basic ERB, so you could just add variables, and they will be dropped into there. It's just that simple. It does require a change in mindset to work with these kind of tools, but this is infrastructure as code in the purest form. Most of us are developers. Infrastructure sometimes is a strange concept that we like to hand over to sysadmins, but this is just giving you the power to define the things you need. You'll turn your sysadmin into a developer, and a developer into a sysadmin, which is the DevOps way of thinking. Typical resources you can tune. This is just a short list. I added the 3 dots. There's more than this. So users, crons, directories, executing commands, files, installing packages, running services, so everything you need. Again, I would advise you to download components that are offered through the community, but if you want to do it yourself, this is a way of doing it yourself. Let's say we create a project cookbook, and in the recipes we add a default recipe. We're going to do an update of our channel, so we have the freshest channel, so we know when we install a package called MySQL Server or Apache that these are the most recent ones. After installing the MySQL Server, you're going to make sure the system starts, so you're going to invoke the service. The Apache server, when it's installed, make sure it's started as well. You're going to do this delayed here. Why? Because there's a next step coming, and that will require a restart of the server as well. So you can actually schedule and script what the entire installation procedure is. And then we continue to assign a root password to the system only if there's not a root password present. We're going to manage a service, so this is an actual service definition that allows us to start, stop, restart systems. So this is your system, your entire installation, wrapped into a couple of files. And when we want to do it ourselves, this is what our Vagrant file, this is what gets exposed to the front, looks like. So we're going to say, we're going to use Chef Solo. This is where the cookbooks are located. We have a project recipe, and the root password of the project is foo. You just do Vagrant up, boom, MySQL server, Apache web server, and a bit of PHP. When you do Vagrant up, you're going to see that there's a provisioning run happening as well. So there's an extra mount being added to TMP, Vagrant Chef, and it contains all the cookbooks because the local machine needs to run the chef through. And you get a lot of verbose information, a hell of a lot of verbose information. I marked the ones that are useful to us, so the services, the execution of all the stuff. So you can really see what's happening, and you can use that to debug in case something goes wrong. That was Chef. Puppet is pretty similar. I think it would be easier for you to follow along right now because you already have a vague idea of what configuration management could do. And Puppet is very, very similar to Chef. It's just a different flavor. You have your cookbooks as well, or modules as they're called. And Puppet Labs has its own GitHub channel as well. Everything is stored in there. it's a bit different how you interact with them. So you have a module path as well, very similar to the cookbook path. But you don't add recipes in your Vagrant file, you just include a manifest, and that manifest is just your bootstrapping file that does all the installations. If you want to transport custom variables, custom attributes from your Vagrant file to the internal Puppet manifests, you can use puppet.factor and add custom facts, and these will become variables within your script. So Vagrant file looks a bit like this. Manifest path, module path, manifest file. So the init.pp resides within the Puppet manifests folder, and it looks a bit like this. So with this single line, you can set up a MySQL server, just install it. It won't contain a password, so if you connect your localhost, just MySQL, enter, and you're in the system. If you want to tune it, you have to turn this into an actual class and add a parameter root password equals foo, vagrant up, good to go. Now the layout of this module is pretty similar to Chef. If you ask me, Chef or Puppet, it's like choosing between Pepsi and Cola. Everyone has its own preference. Manifests, instead of recipes, you have your init.pp. This is the one that's going to get bootstrapped first. And instead of having an attributes folder where all the attributes are located, by convention, people are mostly going to use parameters.pp, and this contains a bunch of parameters. Again, there's a template folder containing all the basic templates. I have a screen dump of what this looks like. This is, you see, a more object-oriented approach, a whole lot of parameters you can tune. This is just a piece of the action. There's plenty more. I added some dots there. You can see there's differences. For Red Hats, you can do this. For Debians, you can do other stuff. So there's a huge list of options to tune. The manifest itself, see, MySQL server, so we're going to install a server. It inherits from the parameters. You have some templates too. So very, very, very similar. And again, the resources are simple too. I mean, files, execution, computers, cron, hosts, whatever's in Chef is probably also in Puppet. And if you want to do it yourself, this is what it looks like. Now, there's a very important difference between Chef and Puppet in terms of writing it into a file. In Chef, it's going to go top-down, as you expect it to be. In Puppet, it is not, and that freaked me out when I learned Puppet first. You have to chain events to each other. So this is going to be executed whenever Puppet feels like it, so we're going to update our channel. But the way we're going to make sure there's a logical order is by using require and notify to change things to each other. So if we install the MySQL server package, before we do that, we're going to make sure our channels are updated. And after that, we're going to make sure the service is started. So that's the way you order things. When you install Apache, it could be that MySQL is installed first. It could be on the next run that Apache is installed first. But that doesn't really matter. What does matter is when you want to install Apache, make sure the channel is updated. And right after that, make sure you install PHP. And when you install PHP there, make sure in the end, after you install both of these components, that you reload Apache. That freaked me out. That was really complicated. And this is the remainder. Before you assign a root password, make sure the MySQL server is installed. And do this only if you can just execute that command and get in. If you get an access denied, it means you already have a password. No need to reconfigure it. And then in the end, you have your two services, a MySQL service and Apache service. Whereas Chef is just blocks. This is like more curly braces style. Depends on what you want to do. And this is just the basic file. Manifest path, module path, main file you're going to include. The Puppet factor, see foo, and foo is used there. Root password, you see, just a $sign password. You define it here. It finds its way from your Vagrant all the way up to the system internally. And you're done. And this is what happens when you type Vagrant up. 2 new mounts, a manifest mount, a module mount. And you can see all sorts of information, services, executions, packets being installed. This is the random order that happens. That being said, so we're through the Chef. We've already done Puppet as well. In a lot of cases, I said Vagrant up is the main command you need. In a lot of cases, the machine will already be there, and you made an error in your provisioning. You can just type Vagrant provision. It won't reboot the machine. It will just run the Puppet or the Chef, or both, because you can combine all of them. You can have a Chef run, a Puppet run, a shell run, or an Ansible run, all run through each other. Main question at the end, Chef or Puppet? What are we going to choose? After this, who's going to prefer Chef? Puppet? A slight majority for Puppet, if I can say so. But there are problems as well when using Chef and Puppet, and I noticed this. So my colleague Bram, who's sitting on the 3rd row there, asked me, Thijs, make me a dev box, and this is my list of requirements. and I scripted it all, and then I typed vagrant up, and it took about half an hour to boot the entire system up, because it had so much dependencies that went over the network, because using a package manager implies that you make connections outbound, and I didn't configure my system as such that it took geolocality into account, so it just went off to connect to the US servers and started downloading. So it was very cumbersome, very time-consuming, so I decided we need a different approach. So what I did is, instead of just installing everything on the fly, I created a new base box, because it can be slow from time to time. Maybe some other lessons learned before we dive into the final piece. The quality of public cookbooks and manifests and the support you get may vary. So when you choose a specific cookbook or module for Chef or Puppet, make sure it fits your requirements so that it is built around your distribution, because I have found some pretty awesome scripts, Puppet scripts, that only work on Red Hat systems, and I use a Debian. But make sure it works, make sure the quality is there, make sure it's updated regularly. My main advice is if you stick with Chef, go to the ops code, GitHub, and get one of those. These are well maintained. And for Puppet, it's the very same thing. But getting back to the story of the VM I had to create for my colleague, it was so time consuming to set it up. It wasn't really working. We have several projects we have to work on, and if you type Vagrant up for this project, and in the afternoon you have to work on another project, it doesn't really work. So what I did is use the Vagrant Package command. And the Vagrant Package will just take the current VM you're working on and repackage it as a box file. And that box file, you can re-upload it elsewhere. So what I did is I installed all the software he needed, all the configuration files were in place, and the only thing he needed to do was make sure he had that box in his Vagrant file and in a full-blown box ready to go. This is time-consuming as well to package it, because it has to export the entire VM, turn it into a box file, tar-gz it. So it's a trade-off. And another thing you could do, and this is a very good practice, is do light provisioning. So everything that is pretty heavyweight, so in terms of installing software, making connections with packages, you can do that in the box file. And all the configurations, like configuration settings, virtual host files, you could still do that using Puppet, Chef, or Shell, because that doesn't really take any time. That's just file system action. When you have to connect outbound, you might want to figure out a way. There are people who just use deb files or RPM files that just store them on the system, so they don't need to connect to the network. They have all the packages at hand. There are even people who boot a specific VM that serves as a sort of package server, and they connect to that. It's pretty much up to you. I have 3 minutes left in this talk, and I want to dedicate it to multi-machine setups, which is a very interesting concept when you want to take it to the next level. When you work at a decent company or work on a product, it's hardly going to be run on a single machine. In a lot of cases, you're going to have multiple machines, 2 web servers, 2 MySQL servers, an Oracle, some Redis, whatever you want. So it would be nice to see this in action too. I'll show you a Vagrant file. I hope this is readable at the back. This was usually done in the main piece, but what I do now is config VM define, and I'm given a name. We have a web server, we have a DB server. This is shared along, so these are both Debian Wheezies. So we just say that once, we just mention it once, Debian 7.10. And on every other machine, I'm going to do a shell inline script, update the channel, update the packages. And then the specifics are noted here. We're going to define a host name for the machine, because default won't really cut it right now. So we're going to have a web node and a DB node. And when you log in, you'll be vagrant@web or vagrant@db. You assign a specific IP address, 10.11. The web server is going to need a mounted folder on var dub. Then the other one is going to require a specific password for the MySQL. And the only difference here is that we connect to web.pp in the manifest folder or db.pp. And these are separate scenarios that run, and you can have a MySQL server and an Apache web server running in parallel. And this is what it mainly looks like when you do it. We had default, and all the other slides that were default here, now it gets named to the host name you give the machine, either web or DB in our case. And you can see what happens here. And the very final thing is controlling these machines, because if you have multiple machines and you do vagrant SSH, where are you going to end up? These are all the commands again. So vagrant up will boot up all the machines. If you have 10 machines you define in the Vagrant file, your system is going to set up 10 machines. Be careful with that, because it might consume a lot of CPU, might consume a lot of RAM. So be careful. When you do Vagrant SSH, you're going to log into the primary VM. And the primary VM, I'm added primary here, so that's your primary one. When you type Vagrant SSH, you're going to end up in this one. When you do Vagrant destroy, all your boxes will be destroyed. And then you could name them, Vagrant up web. I just want to boot up the web VM. SSH into the web VM, Vagrant SSH web. Vagrant destroy web, Vagrant up DB, Vagrant SSH DB, and Vagrant destroy DB. And that's all I have to say for today. Remember, people, Vagrant up saves your life. Thank you.